This video will be our last for the carboxylic acid unit, and it will bring us right into our next unit, which is about enols and enolates. And we'll talk about the decarboxylation reaction of carboxylic acids. And in this reaction, we will see there is a loss of carbon dioxide from carboxylic acids. So the general scheme we of course start with a carboxylic acid. And carbon dioxide is produced along with the carbon chain bonded to a hydrogen. So let's trace these atoms. We have the carbon, the carbonyl carbon, and the two oxygens that it's bonded to. Those are now existing as carbon dioxide. And then this hydrogen and the rest of the R group are bonded in this group here. So there are specific carboxylic acids that are readily decarboxylated in acidic solution, and those are beta keto acids. So beta keto acids are readily decarboxylated in acidic solution. Okay, so first off, what is a beta keto acid? Well, if we have a carboxylic acid, remember the adjacent carbon is the alpha carbon. So the carbon bonded to the alpha carbon is the beta carbon. So when that beta carbon is a ketone carbon, so now we have another carbonyl bonded to another R group, we'll say just a methyl group there. The alpha carbon must be a CH2. This is a beta keto acid. So the beta carbon is a carbonyl carbon. So these are readily carboxylated in acidic solution. And we'll draw out a few steps to explain why that is. Well, if we rotate this carboxylic acid, carbonyl carbon, bond to the alpha carbon. So we're going to rotate this bond. And essentially we'll switch the locations of the OH group and the carbonyl oxygen. So if we rotate the bond, all the carbons are in the same place. The ketone carbonyl is in the same place. Now we have single bond to oxygen above the carboxylic acid carbon, and then the carbonyl oxygen to the right. So I'm going to intentionally draw the hydrogen a little bit to the left. So when we have a beta keto acid, that oxygen that's part of the ketone part of the molecule can form a hydrogen bond with the hydrogen that's from the carboxylic acid part of the molecule. So here we're representing a hydrogen bond. Now this sets up the next part of the reaction nicely, where the ketone oxygen will formally form a bond to that hydrogen. And the bond to that hydrogen breaks, we have a negatively charged oxygen there. So if we show the result of this, we have all the atoms still in the same place except for the hydrogen. So now we have the ketone oxygen bonded to the hydrogen, and negatively charged oxygen as part of the carboxylic acid group. Now once we're here, the negatively charged oxygen creates a double bond to the carbonyl carbon below it, the carboxylic acid carbon. The carbon to carbon single bond breaks and will form a double bond between the two carbons on the left, and the pi bond between carbon and oxygen will break. So the result of this now, we have methyl group bonded to a carbon that's now single bonded to an OH group and double bonded to a CH2. And then we have carbon dioxide. So we've lost carbon dioxide, the carbon and the two oxygens from the carboxylic acid group. And then the other part of the molecule now has become what we call an enol. An enol, En, means we have a carbon to carbon double bond, which we do have in that molecule. And the Ol means we have an alcohol or an OH group, which we also have in that molecule. So an enol is when there is one carbon, so this central carbon here, that's double bonded to another carbon and bonded to an OH group. In these enol molecules, they rapidly, we call this tautomerize, into the keto form. So let's copy down this enol here. So here is the enol. In solution, enols are in equilibrium with their keto form. Now the keto form is where we still have the methyl group. We still have 3 carbons bonded in a row. But now the double bond will be to oxygen, and instead of a CH2 group on the right, we have a CH3. So this is the keto form of that specific enol that we've shown on the left. And this is called tautomerization. And we say that this enol and this ketone are tautomers of each other. So in future videos, we'll talk more about these tautomers and tautomerization.